So in this particular question, we have to prove that the term which is independent of x in the given binomial expression is given by this particular form. So let us begin by assuming that our r plus 1th term is independent of x. Such that when we compute the r plus 1th term, that should give us 2ncn times the first term, which is x raised to the power of 2n minus this is not n, this is r, 2n minus r times 1 over x raised to the power r, which will be equals to 2ncr times x raised to the power of 2n minus r divided by x raised to the power of r, and we finally get 2ncr x raised to the power of 2n minus 2r. Now, since we have to make this term independent of x, so we let 2n minus twice of r to be equals to 0, and on solving for r, we get r is equals to n. So therefore the term becomes t n plus 1 is equals to 2ncn, and we have x raised to the power of 0, so 2ncn. So now we expand 2ncn, so that gives us 2n factorial divided by n factorial times 2n minus n is simply n factorial, which will be equals to, let's go downstairs, 2n times 2n minus 1 times 2n minus 2 all the way up to 3 to 1 divided by n factorial times n factorial. So this is our independent term tn plus 1. And what we have to do now, we're going to write this product in such a way that all the odd terms are together. So that would be 1 times 3 times 5 up to 2n minus 3 times 2n minus 1. So we are separating the odd terms and writing the product together, and then we're going to write the product of the even terms together. So that would be 2 times 4 times 6 times all the way up to 2n minus 2 times twice of n divided by n factorial times n factorial. Then we keep the odd terms the way it is, so we have 1 times 3 times 3 all the way up to 2n minus 1. Now what we're going to do, we're going to take out, or we're going to factor out 2 from each of the terms. So from the first term we take out 2, that leaves us with 1, so we write as 2 times 1. So okay, 2 times 1. Then from the second term we take out, factor out 2, that leaves us with 2 times 2, so we have 2 times 3, and the final one would be 2 times n minus 1 times 2 times n. The entire thing is divided by n factorial times n factorial, which is equals to 1 times 3 times 5 times up to 2n minus 1. Now we multiply each of the 2 that were factored out from each of the even terms, and that should give us 2 raised to the power 1 plus 1 plus all the way up to n times. And then we are left with 1 times 2 times 3 up to n divided by n factorial times n factorial. So this will be this 1 times 2 times all the way to n. This term is simply n factorial, so we can factor out n factorial from both the numerator and the denominator, and what we're left with is 1 times 3 times 5 all the way up to 2n minus 1 divided by n factorial times 2 raised to the power of 1 plus 1 plus 1. So 1 has been added n number of times, so we can simply write 1 times n, which will be simply n. So this is the n plus 1th term, which is independent of x and is of the form 1 times 3 times 5 times all the way up to 2n minus 1 times 2 raised to the power n whole divided by n factorial, hence proved.